Hello everyone, welcome to the course on architectural design of ICs. So, in the last class we are discussing about the hardware design for machine learning language or artificial intelligence. So, there are actually wide application of artificial intelligence in various fields. So, that is why we need to develop one efficient algorithm first, and then for we need also efficient hardware which will be designed so that we can actually make the applicability of artificial intelligence to everywhere. So, the overview of deep neural network actually we have already seen. So, the second thing is that now what are there actually the if we consider that how many actually this deep neural network hardware till now the people are already developed or people are still trying to develop. So, if you see that this Intel has in 2016 they have developed one processor, they came up with deep learning processor which is this night landing. It has this 7 teraflops inside of this processors which is having this 16 GB MCD RAM, and then it is being made in 14 nanometer process. Okay. So, this is this the Knight's Mill is the next generation Xeon Phi optimized for deep learning, that means process. So, then we are having this NVIDIA Pascal which is another example of deep learning processor. It is also made by 16 nanometer process. Then we are having this NVIDIA Volta which also has the capability to do the deep learning, and it is being made by 12 nanometer process technology node. Then actually we are having this GV100 tensor core which is having this capability of 120 teraflops operation it can do. Then we are having this NVIDIA DGX1 in 2000 developed in 2016, and it is basically having 170 teraflops to do the corresponding operation. That means, all these particular this deep learning processes, they are comes up with a huge processing capability. Okay. So, this is one of the Facebook's deep learning machines where it is powered with M40 GPUs, and then we are having this NVIDIA Tegra, and in NVIDIA Tegra this GPU consider this 1.5 teraflops. Okay. And the process it is used which is the 16 nanometer technology. Then we are having this Samsung Exynos which is of this Exynos 8 octa-core processors. Then we can use this FPGA, Xilinx FPGA, this Xilinx, this Vertex Ultrascale. You can use this particular FPGA for deep learning hardware. So, then actually what is this DNN accelerator architectures look like? If you see that this is the generic processors architecture where you are having this memory hierarchy, and then you are having this register file where each of these arithmetic logic units they are basically connected like this. But in case of this machine learning processes, if we have to develop, so at that time we have this ALU to be directly connected with the memory access, So, why I need actually in this particular for machine learning hardware where memory access is the bottleneck is that suppose the ALU which consists of this MAC unit. So, for memory read I need to read 3 actually component. So, one is this filter weight, another one is this map activation, and then the partial sum, and depending on that the updated partial sum it will be again stored in the memory back. So, that means at that time if I have to train using this AlexNet, which has actually 724 million MAC operation. So, at that time the memory access requirement will be 2896 million number of DRAM access. So, as we know that as the power consumption, whenever we access the memory, whether that is for read and write, the accessing of the memory consumes more of the power. So, that is why if we have to develop one that means efficient circuit, or if you have to close the gap of this the energy requirement in hardware. So, at that time we have to reduce the corresponding memory access. So, how you can reduce the memory access? So, instead of directly accessing the RAM, if we put some extra levels of local memory, okay, at the both for the input side as well as the output side. So, at that time it can reduce the data by data reusing, the method of data reusing. Okay. So, this data reusing methods, it can reduce the DRAM, that means the power, by a factor of 500x. So, if you just see that from actually in case of earlier case of which the requirement memory access requirement of was 2896 million, now use of this extra levels of local memory, actually it came down to 61 million number of memory access for this AlexNet, okay, which is having 724 millions of MAC operations needed for its training of the data sets. So, then actually what it actually now what actually this ALU will modified ALU structure will be, each of this ALU will now consider of this local memory hierarchy. So, in the local memory hierarchy what will be there, actually you will be having some DRAMs, then there will be some global buffers, and the local memory hierarchy says that you will be needing one global buffers, then direct inter processing elements network, that means the processing elements can talk to each other, and the processing elements local memory. So, this the ALU inside it will be something like this, there will be the corresponding operations, there will be the control file, and along with there will be the register file, which will be the size of 0.5 to 1 KB. Okay. So, that means the inside of each of this ALU, now you need the memory for storing the intermediate values. So, then if you see that direct access of the ALU to the DRAM, it, that means the energy cost is 200x times, whereas if we use this global buffer, which is the size of 100 to 500 KB, it reduces up to 6x, and whenever this each of these processing elements that means are connected, that means in this ALU are interconnected, then at that time it again reduces that by 2x terms, and if that means you are having this local memory to each of this ALU, you can just reduce the particular energy cost to a great extent. Okay. So, this is the actually this is the chip which is developed based on that whatever actually technology what I said, that the ALU which is having this local memory as well as the global memory, and they had the each of this local that ALU are interconnected to each other, and then before that means after that they have the DRAM access. So, you just see that the specification of that particular IC is that it is being developed in 65 nanometer technology. The on chip buffer is 108 KB, and the number of processing elements are there in 168, and the processing elements memory is 0.5 KB each, and then the core frequency is 100 to 250 megahertz. The peak performance is 33.6 to 84 giga operation per second. Okay. So, this is one of the, that means IC which has been developed by the research group at MIT. So, now actually we need this energy efficient AI, okay, energy efficient artificial intelligence. Why we need energy efficient artificial intelligence is that now actually we are talking about this cloud computing. What is this cloud computing? Means what? Actually we are having so much data. So, now over the cloud you just send to some processing, that means high processing blocks which are available over the cloud. So, you send the data, process there, and then you get back the data. But as like for so, instead of, but the recent days actually the requirement of recent days AI that needs the edge computing instead of this cloud computing. Why? Because whenever suppose we are actually that means the sending the data, okay, over the cloud. So, at that time the security is one of the major issue which whenever we process this data in online. The other thing is that suppose I am driving one self driving car. So, at that time suppose one obstacle came. So, at that time to send the data, that means at that particular instant to send the data over the cloud, process, and then it will come back and take with the decision, it will take too much of time, which is the network latency. So, if the network latency is more, at that time the accident before getting the that means the decision or the instruction, the accident will occur. So, at that time the that means the cloud computing is not that much beneficial for that kind of application. So, instead we need one edge computing. Edge computing means the computation will be done at the corresponding terminal or corresponding device or the processor itself. It will not send the data over the network because of the security issue, because of this transmission issues. So, the in the device itself it will calculate and take the decision immediately. So, that I can get or I can actually without any this accident or without any mishappening, I can just rely on the circuit. That means, this increases the reliability of the artificial intelligence system. So, this one self driving car prototype use approximately 2500 watts of computing power. So, now actually whenever, and I said that we are in the age of miniature actually system design. So, if we see that this is a small drone, okay, which has the power budget less than 1 watt, and nowadays all the basically systems are miniaturized and they are battery driven. So, the battery driven means their power budget is very much limited. Now, if we can that means within that particular systems, now whenever there is a power budget, unless and until I am designing one, that means energy efficient circuit, I cannot provide the artificial intelligence at the edge. Okay. So, that is why the major challenge in artificial intelligence hardware is that how actually energy efficient hardware you can make, which will support or which will provide this artificial intelligence to the users. So, and then actually if you see the trends in the transistors, okay, that means how these technologies are basically changing. So, if you see the corresponding transistors are not becoming that much that means efficient day by day. So, this is the report which is that got from Intel. Okay. So, that means the performance of the, that means transistors are now, it is not that day by day it is increasing, it is some kind of, it is fixing to somewhere. So, that is why this artificial intelligence with only the help of transistors will not be suffice to do. So, at that time what we have to do, we have to create the new algorithm and the new architecture, everything will be, the concept will be totally new. So, that it mainly focus on the energy efficiency or the power efficiency in the hardware, though the hardware will provide the adaptability or the reconfigurability options. Okay. So, we need that means innovation at the algorithms level, we need the innovation at the system level, we need the innovation at the circuit level, we need the innovation at the computer architecture level. So, that means all these algorithms, systems, architecture, circuits, everywhere I need innovation. That means the concept, that means the generalized actually concept that has to be changed whenever we are focusing to design one artificial intelligence hardware. So, this is the deep neural network I have already developed. So, this is in actually this is one of the this artificial intelligence processor which is named as IRIS. This has been actually developed at MIT, and this work has been published in that means International Solid State Circuit Conference in 2016. So, actually we can use this artificial intelligence in robot, in that means in everywhere. So, if you have heard about the Sophia, which is the first humanoid robot, so it can actually it is the that means living example of the artificial intelligence which is basically put inside of the machines. So, then actually we needs the low energy robots. So, that means for in this lighter than air vehicles, we need the artificial intelligence support in satellites. We have this origami robots. All these are basically low energy robotics application. So, using this AI also, I said that this AI can be applicable to the medical application to detect the cancer, that means to detect the life risking actually diseases like cancer, then the prenatal malfunction also you can predict that okay, if these are the symptoms at that time you are having this. So, we can using of this artificial intelligence we can detect earlier, and then we can take the that means we can take the decision what to do with that patient, or we can, that means we can from the beginning we will be able to know that okay, or we can detect that okay, if there is this problem then this is the outcome of that particular problem. So, then the summary of this is that the energy efficient AI extend the reach of AI beyond the cloud. So, that is why all the particular systems requirement is now actually you need the hardware of this edge in the era of this edge computing, you need the hardware should be much, that means it should be energy efficient, so that I can get the benefit of the high processing power as well as the low energy level. So, that means here if you see the we need the innovation, or we need, there is the challenge and the scope in algorithm development for AI as well as the hardware development for the AI. So, the next generation autonomous intelligent system where we need to focus on the devices, the circuits and the algorithms all together. So, what is the challenge is that in embedded deep learning actually we have to, suppose we are using this Google Glass. Okay. So, using Google Glass I can actually, if I provide the artificial intelligence, so immediately it will recognize and it can be useful for any of the application. So, if you can recognize the object or if you can recognize the person, so at that time you can treat the person properly or you can do anything. It will be just like a human being, what through his eyes what he can see and he can do, or he can take the decision through this Google eyes. If I provide artificial intelligence to this particular Google device, so at that time you can do just like a human being. So, the major challenge is that the battery life, as the battery life it requires a very, that means small amount of energy, which is 5 into 10 to the power minus 2 nanojoule per operation, okay, in mobile GPU. So, that is why actually you need one energy efficient hardware which will be developed, so that the power requirement is reduced and you can do the processing high actually performance processing as well as the power in the lower mode. So, this is the today's deep learning network. It requires massive amount of training data. If you learn actually with it needs actually it needs that you need some algorithm which will be developed where you can train your data with less amount of, that means you can train your network with less amount of data. So, less amount of data if you provide to the network for training, so at that time it will be lesser, that means the processing power requirement will be much more lesser. So, then you need supervised learning, need for higher biofidelity, then the incremental or the adaptive learning is difficult, catastrophic forgetting. So, actually as we need, actually we are human being, as a human being we lifelong we learn. So, the same thing, this lifelong learning also it is needed for this machine learning hardware, and then it needs a huge power consumption. So, event driven that means evaluation can help where we can, that means use this approximate hardware. Okay. This is one of the technique which is used to reduce the high power that means consumption, along with the techniques what we have already seen. So, that means we need the, that means research or we need the focus to make processing elements, that the processing power at its heights along with the power consumption at its lowest. Then this deep learning network is very much well suited for image, speech and text recognition. And can this neuro mimetic device help? That means the people are basically trying to develop one new device. Okay. So, the device level, circuit level, system level, algorithmic level, everywhere you need, you are having the challenge. So, you need to solve those problems. There are the, that means there are the problems. So, if you can, you have to solve the problem so that you can get the better results in terms of a good learning, that means this deep neural network. Okay. So, this is the artificial neural network computing actually structure. That means basically what we are trying to do, we are trying to create one artificial brain which will be put inside of the machines. Okay. And how actually the machines, like us, we are having the brains which is biological, but the machines will be having this brain not like biological, it will be of mechanical or it will be in terms of circuits. Okay. So, this is actually how you can create. I already said that you are having this input layer, then you are having this hidden layer and then you are having output layer. Each of this has been connected with different weight, and these particular weights will be different, or this that means the corresponding weight for different classification or different object detection, this will be different. So, the computation can be mapped to a parallel dot product operation. Actually, this is the earlier actually von Neumann architecture which is used in computer architecture. So, the bottleneck is that, so which leads to this in memory computing. Today people are basically to support this AI, they are providing this in memory computing. The earlier iris chip also whatever we have discussed, there also the each of these ALU contains some of this local memory, then they have this global buffers, then they have this the access to the DRAM. Okay. So, those as basically reduces, as they reduces the write and read of the memory. So, by that they can save the energy. So, the generic von Neumann architecture, for that means the processor architecture has the bottleneck for this memory access which consumes lot of power. So, that is why we need basically in future we need this in memory computing which will be much more efficient for artificial intelligence hardware development. Okay. So, if we just see this brain, So, we have to develop these neuron models, we have to develop these learning algorithms, we have to develop this network topologies, and we have to set the computing principles. Okay. So, whenever we will that means complete all this together, then we can create one artificial brain which will be known as artificial intelligence. Okay. So, the hardware fabrics actually you can use this multi-core GPUs, you can use these accelerators, you can use this approximate and stochastic hardwares, you can use this in memory computing, you can do that then this post CMOS devices or changes in the CMOS devices to get, that means the device itself will be having the corresponding memory itself. So, to all this actually opens up the research scope by what, to close this energy gap which is requirement of 10 to the power 4 with respect to our normal brain to the artificial brain. So, that is why actually there is the scope or there is the options. Now, whatever we have learned in this particular course, that techniques or those whatever learning things we have done, so those things we can apply to make this artificial intelligence hardware more efficient, energy efficient in future. Okay. So, this is approximate neuromorphic system. This work is basically this work is following in Purdue University. So, and then using this approximate architecture, hardware architecture, you can reduce the hardware, that means you can reduce the hardware as well as you can reduce the power consumption too, whereas you are basically compromising the with the this accuracy. Okay. So, then this is approximate memory, and then that means each of this particular model that means the overall deep neural network has been developed using this approximation at different blocks. So, whenever we that means use this approximation hardware, so at that time the accuracy I have to actually I have to be compromised there at the accuracy, but the DNA energy is significantly reduced if we use this approximate hardware for artificial intelligence. So, then again the other option is that this in memory computing, people are trying to do this in memory computing, then this spintronic devices has been developing. So, using these spintronic devices in the device level itself, you can, that means have the memory options, so that it can store the that means it is just like the neurons which store the situation. The same thing you can put in the device level by these spintronic devices. So, there are these research opportunities around at different levels of computing stack, whether that is in this neural network algorithms or whether they are the architectures of these VLSI architectures or these neuromimetic devices and circuits, and everywhere the primary task is that energy efficiency is the critical part of artificial intelligence hardware design, and then theoretical analysis of the computing model, then the algorithm which will take lesser amount of training data to properly train the hardware or train the machines. So, all this creates the scope to work on this machine learning hardware, and again I said the machine learning hardware is not application specific, it is more like adaptive kind of things or adaptive hardware we have to design. So, with this particular lecture or with this vision that okay, if you are more interested in machine learning hardware design, so at that time I think that this course will help you a lot, because actually we have learned the techniques how to achieve or how to get this that means low power, or how to get this high speed, or how to get this low area, that architectural at the architectural level. So, if you are interested in this that hardware architecture which will be developed for machine learning, then you can use this particular, actually you can gain the experience from this course and then you can apply for developing the upcoming or the emerging artificial intelligence hardware design. So, this is it and thank you.